This is the Eastern Washington Low Impact Development Guidance Manual. Part of the project team is Lynn Zickler with AHBL. Lynn is a principal of AHBL, and he has over 40 years of experience as a planner and landscape architect. His role in this project has been the primary consultant and has helped direct the development of the manual throughout the entire process. Lynn has a vast amount of experience and has worked with the U.S. Green Building Council, Master Builders Association, American Institute of Architects, Puget Sound Action Team, and the American Society of Landscape Architects. His works have been featured in many regional and national magazines. I'd like to thank Lynn for being here today and being a part of this project team.
I'm going to just kind of walk through the organization of the manual, the content of the manual, and then we'll actually get into some of the detail. So what we'll be presenting today is talk a little bit about the Phase 2 permit for Eastern Washington, a little on the definition of LID, emphasizing this manual as guidance, not regulation, and then the organization of the manual, our introduction, planning for LID projects, designing for LID BMPs, and then in Chapter 4, we outline, I believe it's 9 different BMPs, and then a very valuable resource will be the appendices. First of all, the Phase 2 permit for Eastern Washington covers 18 cities and portions of 6 counties, and you can kind of see that distribution across Eastern Washington. The deadline for permittees to amend their codes to allow LID is the 31st of December 2017. This manual will provide important guidance to local communities in terms of encouraging and allowing LID in their jurisdictions. And it's interesting, the definition of what LID is has evolved. And one of the things about this manual I think is really important is a decision was made to make sure that our terminology, our language is consistent really across the state. An example of that is in Spokane specifically in response to a couple of our local projects, we've used the term storm garden. We're not doing that in this manual. So the definition here, low impact development, LID, is a stormwater and land use management strategy that strives to mimic pre-disturbance hydrologic processes of infiltration, filtration, storage, evaporation, and transpiration by emphasizing conservation, use of on-site natural features, site planning, and distributed stormwater management practices that are integrated into a project design. A couple of things I'd like to mention about that. The manual includes what we would describe as non-engineered practices and engineered practices. The manual does discuss tools that communities, whether it's a county or a city, can adopt to encourage site planning for LID. For example, clustered site planning, clustered housing, or an important component sometimes is our landscape codes, making sure our landscape codes provide the flexibility to combine or to be used for storm drainage features. I want to discuss the purpose of this manual is to provide managers, site designers, design reviewers a common understanding of LID goals and design of individual practices and flow reduction and water quality treatment that are applicable to Eastern Washington and our unique conditions. The manual features some key elements here. First of all, this is a guidance document. This is not a regulatory document. We're not there yet. We provide excellent and specific best management practice design guidance for those 9 or 10 BMPs. Included in our best management practices are the specific technologies. We've identified infeasibility criteria. That term infeasibility criteria emerges out of the Puget Sound region in terms of the application of LID technologies in circumstances where they're just not feasible. So infeasibility criteria is discussed for each one of those BMPs that are in the manual. And then we also discuss a sizing approach. Very interesting and challenging discussion. I think it was a very worthwhile discussion. I think you'll find that interesting. The focus of this afternoon's exercise will be on the selection and sizing and the application of specific BMPs to our sample site. So I think you'll find that part of our discussion very interesting. It's important, unless adopted by reference through a locally enacted ordinance, the manual is intended to provide design guidance to assist professional designers. It does not replace or supersede local design standards or requirements. The general outline, or the general table of contents for the manual, includes a preface. Talks a little bit about the process that we went through to prepare the manual. We have an overall introduction that describes the setting of Eastern Washington, its varied conditions, and specifically the relationship to the Phase 2 permit. We then broadly discuss planning concepts for LID. How do you organize yourself to think about the application of low-impact technologies to a site? And then Chapter 3 discusses a stepwise process for the design of LID facilities. Our Chapter 4 are the best management practices, and then our appendices. There's some really great technical material in the appendices that I think particularly jurisdictions will find very, very useful. The introduction covers these broad categories. The Eastern Washington hydrology and climate. What makes us different about Eastern Washington, let's say the Puget Sound region? We talk and discuss about the effects of urbanization on hydrology and storm drainage management. We address LID and the NPDES stormwater permit, and then specifically we get into the discussion of the application of these concepts to Eastern Washington. When we're thinking about LIDBMPs, we wanted to think about the eco-regions that characterize the east side of the state. We've got 4 regions that we acknowledge. Region 1 basically consists of the east slope of the Cascades. Region 2, sometimes referred to as the Columbia Basin or the Central Basin. So that would stretch from Richland all the way up to Okanagan, following the Columbia River. Region 3, Spokane, for example, Pullman would be located in Region 3, referred to as the Okanagan-Spokane-Palouse region. And then Region 4, northeastern Washington, but also acknowledging the Blue Mountains in southeastern Washington, actually has many of the same hydrological, soil, and vegetation characteristics. This is a map of precipitation across eastern Washington. I think it's just important to acknowledge that, like western Washington, where, having been born and raised in Spokane, everyone in Spokane, if you've been born in Spokane or the Tri-Cities on the east side and you're raised here, if you think about Seattle, a couple of things come to mind. It always rains in Seattle, right? Well, similarly, it's interesting. I've spent about half my career on the west side in the Puget Sound Basin, and I can't tell you how many times I run into people who have this vision, this picture of eastern Washington, and their picture is sort of defined by their travel down I-90. They haven't arrived to eastern Washington, they cross the Columbia River and they get up around George, and all of a sudden they realize they don't see too many trees. There are a few. And they see this vast area of open space, of, sort of devoid of trees. I think the important thing to recognize here in this diagram is just how diverse eastern Washington is in terms of rainfall, climate, and those environmental conditions. We have areas where our rainfall actually does approach 40 to 50 inches a year. That would be the east slopes of the Cascades, where we do have some permit jurisdictions. And of course, in the Central Basin, we have the other extreme, where we do have an annual rainfall of 6 to 8 inches. So not a lot of rainfall. And then of course, Spokane, Whitman County. In my early career, spent a lot of time in Whitman County, and Whitman County is one of those examples where at the northern reaches of Whitman County, you might have 26 inches of annual rainfall. You get down right at the top of the bluff above the Columbia River, and you'll see rainfall approaching 45, 46 inches in certain areas. Okay, this is a slide that I know most of you as professionals have seen this type of slide many, many times. It sort of depicts the impacts, the effects of urbanization on our storm drainage management. So what we see with urbanization is we see significant changes in natural vegetation and soil structure around communities. We see increased peak flow rates and volumes of runoff, reduced groundwater recharge, and particularly patterns of recharge that change during the course of the year. Alteration of wetland hydro periods, and obviously increased pollutant loadings to receiving waters. So all of these are characteristic of urbanization. One of the things that we can all acknowledge is that Mother Nature does a terrific job of managing storm drainage. And so in LID, one of the things we try to do is mimic those natural conditions, preserve soil, preserve vegetation, or restore vegetation to a natural condition. So some important considerations for Eastern Washington, again, in that theme of what's unique about our setting, what's unique about Eastern Washington. Well, obviously we have cold and semi-arid climates. That would have an impact on the implementation of certain BMPs. We have high evapotranspiration rates. In some areas, we have sparse vegetation, leaving soil prone to erosion. But across Eastern Washington, development patterns tend to be characterized by much lower density. I'm comparing that to, for example, the Puget Sound Basin, and large amounts of impervious area, so large expanses of asphalt, parking areas, and lower density. This is characteristic of Spokane, for example. Many areas where we have shallow depths to bedrock or shallow depths to groundwater, or other restricting conditions in the subsoil sublayers. Interesting thing that we discovered, particularly about the areas around the Tri-Cities in Kittitas County, is we find that their patterns of groundwater, you would think that in August or July, the groundwater levels would be a little lower. Those soils are impacted by a lot of the irrigation that's taking place in those summer months. We all know that Lake Cle Elum, for example, is drawn down about Memorial Day weekend. The rivers fill, and that is all designed for irrigation. And so in Ellensburg and in parts of the area around the Tri-Cities, we actually have higher groundwater levels during July and August. An important one in Spokane specifically is critical sole source aquifers, again, which could affect the feasibility or infeasibility of certain BMPs. And of course, then we also have snowfall here in certain areas, in some cases significant. We have freezing and thawing, which is, now, again, you think about the Puget Sound Basin. Does it ever freeze in certain areas of the Puget Sound Basin? Well, of course it does. And so they have freeze-thaw, they have snowfall. In some areas, it can be rather significant. So like Western Washington or other geographic areas across the United States, I think what we find here in Eastern Washington is quite a diverse climate, diverse vegetation conditions, diverse soil conditions, and diverse hydrologic conditions. The beauty of LID is we're able to, with LID, pick best management practices to respond to those unique specific site conditions that we find across Eastern Washington. So just a little bit of a word, and we want to thank the University of Arkansas Community Design Center for the next series of slides. I would invite you to visit this particular project that was produced. It's really an award winner, but just some myths that we'd like to just discuss and perhaps dispel. We want to talk a little bit about hard engineering and soft engineering. Now, hard engineering is not wrong engineering, it's just hard engineering. And soft engineering is a concept we'd like to present. Some believe that ecologically based stormwater management is unattainable in dense urban areas, but consider the following. That photograph on the left is in a rural community with a population of about 8,000. So in rural communities, we can screw up our stream systems, manage storm drainage very, very poorly. And so that's an illustration of that. Soft engineering concepts, more ecologically based concepts presented on the right slide, This is in an area or community with a population of about 4 million people. So the soft engineering approach is attainable in urban areas regardless of the population, the scale, the size. Another example, hard engineering transfers pollution to another site. So what we have in conventional storm drainage design, catch basin, pipes, and ponds, we are efficiently taking that storm drainage that falls. We are trapping some pollutants in the catch basin, but then we're moving it to a detention facility or perhaps some other facility for treatment. So it's very direct, it's very efficient. Soft engineering tends to metabolize pollutants on site. So the concept there is storm drainage management through parks, not pipes. This is sort of an illustration of the mechanical on the left, that catch basin and pipe sort of concept where pollutants are sort of settle at the bottom of the catch basin and then discharge occurs in a pipe format. And on the right side of the slide is what we try to achieve with LID concepts, and that's more of a biological approach. Phytoremediation, if you will, where we're using soils and plants to nature to manage storm drainage, both in terms of volume and water quality. And the concept would not be to reject hard engineering, but figure out ways to blend the two, use the two, take advantage of both. So we have flow control, we have detention, we have retention on the more engineered side, and we have filtration, infiltration, and treatment on the LID or soft engineering side of the picture. So we want to integrate hard engineering and soft engineering toward more of a low impact design approach. Another, I think, excellent graphic, and the principles of redundancy, resiliency, and distribution model that ecological dynamic necessary to optimize sites' carrying capacity. These are the principles of redundancy. The top slides are a little less effective in terms of redundancy. In LID systems, we tend to look at our systems as a matrix of interconnected systems where there's a lot of redundancy in how stormwater flows. Rather than large static ponds on the resiliency column, more of a natural system is more effective. And in terms of the distribution, if we can, rather than one large pond, for example, more of a series of ponds in place builds in that redundancy and effective distribution. I'll give you an example of this. This last year there was a rather significant storm event in Spokane that impacted recently installed the Lincoln Surge Project. And I want to acknowledge the city of Spokane on that project as a very innovative, very well designed, very well engineered project. It was designed as part of, it's kind of an experiment here, to our CSO problems. And we had a very significant storm event where we actually experienced some failure of the conventional storm drainage system at 29th and Lincoln. A pretty huge volume of water came, basically overwhelmed the catch basins and pipe systems at 29th and Lincoln. That storm drainage overflowed and then headed north down Lincoln Street. Eric Fitzpatrick here of our office happened to be driving by during that storm at that time and took real-time video of what that storm looked like at about 28th and Lincoln. By the time we got down to 25th, the flow-through planters there along Lincoln had basically accommodated that extra runoff, and there was a significant reduction in that volume. And so what that illustrates really is the resiliency and the redundancy of that system. You're not overwhelming a group of catch basins. You're providing a path or a direction where that storm drainage can flow. It's just an extra factor of safety. The storm drainage management plan for Eastern Washington, there are a couple of key goals. We have 8 core elements, but really it's core element 5 and core element 6 that are the critical ones. Core element 5 addresses The issue of treatment, we need to treat approximately 90% of the annual runoff. And core element 6, the goal there is to mitigate impacts of increased runoff volumes and flow rates on streams. Infiltration BMPs, and the Eastern Washington Manual provides guidance on LID principles and BMPs to meet this requirement and other project goals.